Let's talk about parallel and perpendicular equations. So when you have a system of linear equations, there's a couple things that could happen. First, I guess the most common one is that they just intersect one time, right? That's one solution. It could also be that they intersect one time, but when they intersect, they form a right angle. That's a special case, and those are called perpendicular lines. When they intersect, they form a right angle. In both these cases, there's one solution because they intersect one time. You could also have two lines that never intersect, and they would look like this. They would have to be parallel lines for them to never intersect. And they would keep on going forever, but you can see that because of the trajectory that they're on, they never intersect. That's no solutions. And lastly, you could have infinitely many solutions. That happens when you have a line and then you have another line in your system like this that sort of overlaps it. And therefore, at every single point, it's intersecting, right? So it's going to be infinite solutions. Those are the cases that you could have for a system of linear equations. So let's take a look at them more closely. For perpendicular equations, your slope is going to be the opposite reciprocal of your original equation, right? So for example, if I have the equation y is equal to 1/2 x plus 5, we know that this is written in slope-intercept form, where 1/2 is my slope, right? So if I want the equation of the line that's perpendicular to this, I want the opposite reciprocal of this slope. So what it means by opposite reciprocal is the opposite sign and the reciprocal of the fraction, right? So the reciprocal of this fraction, 1/2, you just flip the numerator and denominator, so it becomes 2/1. And the opposite sign, well, 1/2 is positive, so we change it to negative 2/1. That's going to be the slope of the line perpendicular to this equation. And then, we can write the equation y is equal to negative 2/1 x plus 5. I don't think that the y-intercept matters, but we just want to focus on what the slope is, right? And of course, negative 2/1 is the same thing as negative 2. So we can say y is equal to negative 2x plus 5. For parallel lines, it's going to be the same slope, but a different y-intercept. And you can see from the graph that should sort of make sense, right? Because you can see that these two lines are increasing at the exact same rate. The difference is that this blue line started a little bit higher than the purple line, right? And because it started a little bit higher and they're both, going at the same rate, they're never going to intersect, right? You can think of it like this. Let's say your friend John hops in his car and he's going to the store. And then you, 10 minutes later, hop in your car and you go to the store. Or let's say you're not going to the store, sorry. Let's say that your friend John is just going for a ride, right? And he hops in his car 10 minutes earlier than you do, right? And then 10 minutes after he leaves, you hop in your car and you also go for a drive, for an indefinite drive. You're just driving forever, right? If you and John are driving at the exact same rate, there's no way that you'll ever catch up to John, right? Either you would have to be driving faster than he is, or he would have to be driving slower than you are, right? Otherwise, there's no way that you'll catch up to John. You'll always just be 10 minutes behind him. You can think of parallel lines like that, because again, if your starting point is lower or different than the other one and you're increasing at the same rate, then you're never gonna have these lines intersect. And for parallel lines, you want to have the same slope but a different y-intercept. So if we go back to this equation here, right? We said that this was the equation of the line perpendicular to this one. Now let's talk about the equation of the line parallel to this one. So I'm just gonna have the exact same slope of 1/2, but I can change my y-intercept to anything except for 5. So I can do 1/2 x plus 3, right? That's fine. Or any other y-intercept that's not 5. So this would be fine. I can say that this is the equation of the line parallel to this one. And there's multiple answers, right? You could have 1/2 x plus 3, 1/2 x plus 2, or anything except for having the same slope. Now let's talk about when you have infinite solutions. That happens, like I said, when the graphs are overlapping, right? And so they're intersecting at every single point. And this happens when your equations are the same. Like you have the exact same equation for both of your lines. So let's see how that would look like. First, let me rearrange this a little bit. This was perpendicular, then parallel. Now we're going to talk about infinite solutions. Well, the equation for the line that has infinite solutions with this original one is just going to be the exact same. Y equals 1/2 x plus 5. Now you might think that, hey, this is really obvious. I can obviously tell that they're the same equation, right? And usually they won't, equations with infinite solutions won't look like this. Instead, they'll look like this. You have the original equation, but it'll be multiplied by some number on both sides. So let's say I multiplied this equation by both sides on 4. So what happens is I end up getting 4y is equal to, I distribute this 4, right? 4 times 1/2 x becomes 2x, and 4 times 5 becomes 20. So 4y is equal to 2x plus 20, right? And, you know, sometimes they might even rearrange it a little more. They might, you know, put it in standard form and make it like 2x minus, or sorry, negative 2x plus 4y equals 20, right? If I subtract 2x from both sides. They might put it in standard form like this. And now if you look at this equation and this equation, it's much harder to tell that they're the same equation. Remember that you're allowed to multiply an equation on both sides by the same number. It'll still be equivalent, right? So again, now it's much harder to be, it's much harder to tell that these are the exact same equation. So that's how infinite solutions will generally show up.